For my topic today, I am discussing optics, specifically magnification. And while magnification is a fairly common term and idea, what it really means is that it's just a ratio of an object's height over its image height. But what exactly is an image? Well, when light passes through a lens, it travels slower and bends the light, creating a new image of the object. And oftentimes the best way to visualize this is in a ray diagram. So in a ray diagram, we're going to start by drawing the axis, and then we're going to add the lens in the middle. Now we're going to add our object, and it's depicted as an arrow on the left side, and then we're also going to add in a focal point on the right side of it. So now we're going to visualize the rays going through the lens. And I'm going to apologize beforehand because these lines are not straight at all. But we're going to start by going from the top of the object, and we're going to go through the midpoint of the lens. So we're going to just draw a straight line through there, like so. And then next we're going to do a horizontal line from the top of the object through the midpoint of the lens and go through the focal point, and it's going to intersect with the other line. This is where our image is going to be. So I'm going to draw that image in red. And there we have our image after going through the lens. So now we can see that with our ray diagram, we have our original object, and now we finally have the image after the rays go through the lens. And now we can actually see that ratio a little clearer of our object height and our image height. But sometimes it can be difficult because we don't often know the heights. But what we do know is the distance from the lens, which we can use in the magnification formula and not the ratio. So we can still calculate it. So as you can see, the object distance is just from the object to the middle of the lens, and same with the image from the middle of the lens to the actual image. So now we're just going to add some values just to make things easier when calculating. So we're going to give our object distance 0.5 and our image distance 1 just to make things super simple. So we can plug these into our magnification formula, which is just negative object distance over image distance. So plugging those numbers in, it's going to be magnification equals negative 0.5 over 1, which gives an overall magnification of negative 0.5, as expected. So now we can plug these back into our ratio of our heights. So our object height over our image height is just going to also equal negative 0.5. So in other words, you can write this and visualize this as our image height being double the size of our object height. And that's also depicted in the ray diagram, as you can see. But notice we still have that negative. So what does that actually mean? Because the sign in this case does matter. As you can see in the ray diagram, it is inverted image. This indicates that our magnification is negative and therefore is a real image. Real images are formed when the object is placed outside the focal length of a converging lens and are always inverted. On the other hand, we have virtual images, which are produced by a diverging lens or when an object is placed inside the focal length of a converging lens. These are always upright. So we can look at ray diagrams all day if we would like, but what does magnification look like in real life? What does an actual lens look like in terms of magnification? And one of the ways I see it in my life the most, literally, is with my glasses. And so I was going to demonstrate just how magnification of lenses can work in my eyes so that I can see better because I have terrible eyesight. So here I'm going to show you what it looks like without glasses and what it looks like with glasses for people who don't know. So what we're doing here is I'm just showing you a quick little scan of what it should look like with my glasses on, or with anybody's clear vision, what people should be seeing. Everything's pretty clear, but then I'm going to put the glasses up to the camera lens, and I'm going to focus on one object, and I'm going to take the glasses away, and now everything is out of focus. And this is how I actually see without any corrective lenses in. You can see that the book and the words are all pretty blurry, and this just goes to show how magnification in my lenses, despite whether you're farsighted or nearsighted, can really impact how I see and can contribute to seeing clearly. So I hope you learned something about lenses and optics, and thank you.